Hello everyone. First and foremost, best of luck to all the first year engineering students who are going to attempt their VTU university examinations, which is going to start from May 12th. VTU has already put out model question papers in their website. Those who don't know, I'll put the link of the question papers where you can download in the description box. You can download it from there. So in this video is intended to help those students who are finding out to solve the problems of basic electrical engineering slightly difficult compared to others. So there are two sets of question papers which of basic electrical engineering which VTU has put out. So I'm trying to solve some of the problems from both the model set question paper 1 as well as set 2 model question paper. So as you can see from the PDF, this is one of the set of the question paper which VTU has put out. So I'll be trying to solve the questions, the problems of module 1 and module 2 in this video. So if you see in question number 1 and question number 2, there are totally two problems. So I'll try to solve these two problems of module 1 now. So coming to the 1C question, which is put out by VTU and set 1. So 1C tells you that the equation for an AC voltage is given as V is equal to 0.04 sine 2000 t plus 60 degree volts. Determine the frequency, angular frequency and instantaneous voltage when t is equal to 160 microseconds. So let us start solving now. So solution. The moment you see the question, you better to write a given data so that it will be very easier for you to know what formula to be applied and how to solve. So if you see this equation, V is equal to 0.04 sine 2000 t plus 60 degree, it is of the form of V is equal to Vm sine of omega t plus some angle or phase some theta. So now from the given data, you can see that Vm is given as 0.04 volts. Then another thing which is given is omega. Omega is nothing but 2000. The unit of omega is radians per second, and then you have been given theta is equal to 60 degree. They have told you to calculate, determine the frequency, F is equal to question mark, angular frequency that is equal to omega, and then instantaneous voltage that is V is equal to question mark at T is equal to 160 microseconds. So this is what is a given thing which is present over here. So let us solve now. As the second part of the question, you can already see angular frequency omega. Omega is given already. So one part of the question you have already solved, that is 2000 radians per second. Next, you need to calculate, determine the frequency. As omega is equal to 2 pi f, which you already know. F I can write it as omega divided by 2 pi. That is equal to 2000 divided by 2 pi. Pi is equal to 3.14. If you solve this, you are going to get the answer of F as 318.3098 hertz. So always take the precision of 4 digits after the decimal point. So you got this frequency component. Angular frequency is already done. Now you need to calculate the instantaneous voltage when t is equal to 160 microsecond. Okay, so now let us substitute. You know that V is equal to Vm, that is equal to 0.04 sine of omega is already given 2000 into 160 micro, then plus 60 degree is what is given over here. Now if you take this 2000 into 160 micro, you are going to get a 0.04 sine of 0.32 plus 60 degree. Now what is 0.32? Is it in degrees or is it in radians or some other unit? You know that 2000 is nothing but, if you see this, 2000 is nothing but radians. The unit is radians per second and 160 micro is in second. So when it cancels out, when you multiply it, you are going to get the answer in radians. So it is 0.32 radians plus 60 degree. So first and foremost, your job is to convert radians to degrees. How do you convert radians to degrees? Now you know that we know that pi radians is nothing but equal to 180 degree. So if 0.32 radians is there, what is a degree? So cross multiply and you will get the answer as that is equal to 0.04 sine of, if you convert it will be, so in degrees it will be 0.32 into 180 divided by pi will give you the answer in degrees. You are going to get it as 18.3346 degrees plus 60 degree. So now you can add directly. You cannot add radians as well as degree directly. So now once you convert it into degrees, you add directly, you will get the answer as 0.03917 volts. So this is the instantaneous value of the voltage at t is equal to 160 microsecond. So if you see the question, instantaneous voltage is calculated, frequency is calculated, angular frequency is also calculated. So finally you have answered all the three. One is F, one is F, one is omega, and the last one is V. So all the three parameters you have calculated. So this is 1C question of the model question paper 1 of the VTU. Next, coming to the second problem, that is 2B. That is also from module 1 only. If you see the question paper, modules question number 2 and question number 2b. So first let us understand the circuit containing 12 ohm, 18 ohm, 36 ohm respectively joined in parallel is connected in series with the fourth resistance. So the moment you know the question is on DC circuit, it is always better to first draw the circuit. Let us break the sentence. A circuit containing 12, 18, 36 ohms respectively joined in parallel. So it is given that uh, you have three resistors which are connected in a parallel. Okay, one of 12 ohm, one of 18 ohm, and the third one is 36 ohm, which are connected in parallel, is connected in series with the fourth resistance. So is connected in a series with the fourth resistance. Let me name it as R. Okay, they have not given the value. The whole is supplied with the 60 volt and it is found that, so the whole combination is supplied with the 60 volt. So the supply voltage is 60 volt and it is found that the power dissipated in 12 ohm is 36 watts. So power dissipated in 12 ohm is equal to 36 watts is given. Determine the value of the fourth resistor. So R is equal to question mark and the total power dissipated in the group. Total power dissipated in the group is asked. So question mark. Now, with there is only one given data, that is 36 watts across 12 ohm is given. So power across 12 ohm is given, power is given, and resistor is given. So based on these two, you can calculate one parameter. You know that power is equal to, we know that, we know that power power is equal to V square divided by R. Now what is V and what is R? Now whenever V and R is there, V is nothing but wherever the power is at across which resistor power dissipation is given. So you are the voltage across it you are going to calculate. Now power is given across 12 ohm. So power is 36 watts. That is equal to V square. V square, I don't know what is the voltage across 12 ohm. The overall voltage is given as 60, but the voltage across 12 ohm is not given, so I'll keep it as it is V square divided by R. The value of R is 12. So if I solve this cross multiply and solve, I'm going to get, that implies V, I am going to get it as 20.7846 volts. So this is a value of the voltage across 12 ohm I am going to get. Now, as 12 ohm, 18 ohm, 36 ohm all are connected in parallel, the voltage drop across all the three resistors will also be same, that is same as 20.7846. So, which means that the voltage over here, the voltage across all the three parallel resistor will be 20.7846 volts. Okay, so now coming back to the question, now I need to calculate what is a voltage drop across R. What is it now? So as you know that energy can neither be created nor be destroyed, but it can only be transferred. So 60 volts what I am supplying, it is transferred between this resistors, all the three resistors, as well as the unknown resistor R. So what is the voltage? VR, voltage across R ohm, that is equal to, I can write it as 60 minus 20.7846. So if I do that, I'm going to get the value of the voltage as 39.2154 volts. So this is a value of the voltage across it. But still I don't know what is the unknown value, because this only I know the voltage, that is 39.2154 volts is known, current is also not known, and R both are unknown. So what do I need to calculate? I need to calculate what is the current flowing through R. Now the current flowing through R is nothing but the current flowing through all the three resistors. Let me consider that the supply current is I. This I, when it enters this node, it gets split up as I1, I2, I3 across the three resistors 12, 18 and 36. Now all the three will combine together, and then it will again flow. I1 plus I2 plus I3 will be nothing but equal to I. Now this will flow through R. Now my job is to find out what is I. As you know that if you apply KCL, we know that I is equal to I1 plus I2 plus I3. Now I need to calculate what is I1. I1 is nothing but the voltage across, sorry, the current through 12 ohm. So voltage across 12 ohm, V across 12 ohm divided by 12, that is RV by R, right? So that is your Ohm's law. Voltage across 12 ohm is nothing but 20.7486. So 20.7846 divided by 12 will give me a current of 1.73205 amperes. Similarly, I2 will be equal to 20.7846 divided by the second resistor, that is 18 ohm. So 18 ohm. Similarly, I3 will be 20.7846. Voltages will be same because voltage drops across all the three resistors are same because all the three resistors are connected in parallel. So I3 will be divided by 36. So your I2 will be nothing but, if you solve, it will be 1.1547 ampere. Similarly, I3 will be equal to 0.57735 amperes. So if I add all the three, I will be nothing but equal to I1 plus I2 plus I3, which will be 3.4641 ampere. So you got to know the value of the current I, supply current. The same current I is flowing through R because this parallel combination is connected in series with R. So in the series combination, the current flowing through the resistors will be same across this combination should be same as the current flowing through this resistor R. So you know the value of the current, you know the value of the voltage across R. So easily you can calculate what is R. You know that, we know that V is equal to I into R. V across R is nothing but the current flowing through R. So VR is nothing but 39.2154, 39.2154, that is equal to current is 3.4641 into R. So that implies you're going to get the value of R as 11.3205 ohm. So you have calculated the first part of the question. The second part of the question is, what is the total power dissipated in the circuit? So power is equal to, you know that it is V into I. Power voltage is, supply voltage is 60 and the supply current is 3.4641 ampere. So you are going to get it as 207.846 watts. So this is how you solve the questions which are asked. So determine the value of the fourth resistance, calculated total power dissipated. So this is all about module 1 questions which is there in the model question paper. Coming to the module 2. So coming to the module 2. questions which is given. So 3B question number is a problem which is given in the model question paper. So let us solve this. A circuit consisting of a resistance of 20 ohm. So R is equal to 20 ohm and inductance L is equal to 0.05 Henry are connected in series. So let us draw the circuit. So you have a resistor, you have an inductor which are connected in series across an AC supply. Okay, so which is 230 volt, 50 hertz AC supply. Resistor is given 20 ohms. Inductance is given 0.05 Henry. Determine the current. I is equal to question mark. So I is nothing but the RMS value of the current which is asked. Power factor which is nothing but cos phi, and the power consumed by the circuit is asked. So these are the things which is asked. For a series RL circuit, you know that R is given, L is given, I is you need to calculate. Supply voltage is also given. The supply voltage is RMS value which is given. So 230 volt AC supply. Frequency is given 50 hertz. Frequency is given 50 hertz. So now you need to calculate all the other parameters. So how do you calculate it? You know that first XL is equal to 2 pi FL. The reason why you are going to calculate XL is because to calculate the current I, you know that Z is equal to, you know that we know, okay, let us remove this. Okay, we know that Z is equal to V divided by I. V is already given. V is nothing but VRMS. You can also write it as Z is equal to VRMS by IRMS, or it is also equal to VM by IM. VRMS is known, that is 230 volt, which is already given in the data, but I you do not know, Z you do not know. So what you have to do first, you need to calculate Z so that you can calculate the value of I. How do you calculate it? So let us solve from this step. I am going over here. Okay, so now you know that Z is equal to square root of R square plus XL square. So that is a formula for a series RL circuit. You also know that also XL is equal to 2 pi FL or omega L. So substitute 2 pi into 50 into 0.05. If you calculate, you are going to get XL as equal to 15.7079 ohms. So this is how you calculate the value of XL. Once you calculate the value of XL, use the formula for Z. Z is equal to square root of R square. R is given, what is the value? It is 20 ohms. So 20 square plus 15.7079 square, and under root it is. So if you solve that, you are going to get it as 25.4311 ohms. So this is a value of Z. Once you know the value of Z, you can calculate the value of I using this formula. Z is equal to V by I. Z is equal to V by I. That implies IRMS will be equal to VRMS divided by Z. So VRMS is 230 divided by 25.4311. You are going to get it as 9.044 ampere. So IRMS is known. So first part of the question you have solved. Next they have asked what is cos phi. As you know from the impedance triangle, we know that from the impedance triangle, you know that x-axis is R, y-axis is XL, resultant is Z with a phase angle of phi. So you know that cos phi is equal to adjacent side by hypotenuse R divided by Z. So cos phi is equal to R, you know, 20 divided by 25.4311. So you are going to get, that implies cos phi is equal to 0.7864. So this is a value of the power factor. The last one what is asked is what is the power consumed by the circuit. You know that for a single phase AC circuit it is P is equal to VI cos phi, right? So VRMS, IRMS, cos phi. VRMS is 230, IRMS is 9.044 into cos phi. Cos phi is nothing but 0.7864 It is, please remember, this is not Vm Im, it is Vrms Irms cos phi. So if you do it, you are going to get P is equal to 1635.8867 watts or 1.635 kilowatt. So both the questions you have solved, three questions you have solved. One is I cos phi as well as the power consumed by the single phase AC circuit. So this is how you're going to solve the question of AC circuit. So next, let us solve the next problem, which is of 4B. Again, it is from the same module, for second module. When a three-phase, and it is of a three-phase AC circuit. When a three-phase balanced impedances are connected in star, so first and foremost, you note that it is a star connection across a three-phase 415 volt. 415 volt is a line voltage, what is given in the question. Frequency, it is 50 hertz, and the line current which is drawn, IL is equal to 20 ampere at a lagging power factor of, power factor is nothing but cos phi. So 0.4, they have told it as lagging power factor. Determine the parameters of the impedance in each phase. You don't know what is there in each phase, whether it is RL or RC or whether it is pure R. But they have, if it is pure R, the power factor will be unity, but power factor they have given it as 0.4, and since they have mentioned it as lagging power factor, as you know that in the case of an inductive circuit, the current is always lagging the voltage by some angle. So which means that in the question itself they have given that it is an RL circuit. You need to calculate what is RP. RP is nothing but the resistance in each phase, and you need to calculate what is the value of ELP in each phase. So first you know that it is a three-phase AC circuit, three-phase AC circuit with RL in each phase, and it is balanced. Balanced means the parameters, this is your Z impedance. Okay, so Z impedance of all the three phases are same. Of all the three phases are same. Now let us start solving. You have EL and IL. You need to calculate what is first Z. In the case of a three-phase AC circuit, Z is appearing across each phase. So ZP will be nothing but equal to EP divided by IP. Similar to your single phase, Z is equal to V by I. In a case of single phase, VRMS by IRMS. Here it is EP by IP. Please remember it is not EL by IL. The reason is the impedance is present across each phase and not across the line. So EP divided by IP. Now what is EP now? In a case of star connection, in star connection, you know that EL is equal to root 3 times EP. That implies EP is equal to EL divided by root 3. Therefore, I can write ZP is equal to EL divided by root 3 whole divided by IP. Now, EL by root 3 is 415 divided by root 3 whole divided by IP. In a case of a star connection, you know that line current is equal to phase current. So IP is also equal to 20 amperes. So if you solve this, you are going to get ZP as 11.98 ohms. So once you get the value of ZP, then it is very simple. Now you know that in a case of power factor, cos phi will be equal to RP by ZP because it is an RL circuit. So you can write RP, that implies, and cos phi is given as 0 0.4. 0.4 is equal to RP is nothing but not known divided by ZP is 11.98. So that implies you can write RP is equal to 4.792 ohms. So you know the value of RP. So first part of the question is calculated. Next you know that ZP is equal to square root of RP square plus XL square, right? So it's an RL circuit. That implies ZP is nothing but 11.98 square is equal to square root of 4.792 square plus XL square. Now, if you solve this, you are going to get the value of XL as equal to 10.9798 ohms. So once you calculate the value of XL, you can easily calculate the value of L. Now, how is it calculated? You know that XL is equal to 2 pi FL. Do not get confused, students. XL is equal to 2 pi FL. So that implies L is equal to XL divided by 2 pi F. That is equal to 10.9798 divided by 2 pi into frequency is given as 50. Is it given? Yes, 50 it is given. So 2 pi into 50. If you solve this, the value of L will turn out to be 0.0349 henries. So this is the value of L. That is what is required in the problem. So this is how you solve this problem. The final problem of module 2 of models question paper 1. So of module 2, a balanced three-phase star connected system, okay, star connected system draws a power of 440 volts. So EL line voltage is given 440 volt. The two wattmeters connected indicate 5 kilowatt. So two wattmeters, let me name it as W1, 5 kilowatt, then W2 as 1.2 kilowatt. Determine the power is equal to question mark, then power factor cos phi is asked question mark, and current in the circuit, so line current you have to calculate question mark. So you know that in a case of derivation we do it where two wattmeters are sufficient to calculate a three-phase power. You know that power is equal to root 3 EL IL cos phi, that is equal to W1 plus W2. Okay, now W1 plus W2 will give you the overall power in a three-phase AC line. So power is equal to W1 5 kilo plus 1.2 kilo watts. So it will be power is it nothing but equal to 6.2 kilowatt. That is a power in a three-phase AC circuit. Next, you need to calculate what is cos phi. You know that tan phi is equal to root 3 into W1 minus W2 divided by W1 plus W2. So this is a formula which you have. So that implies tan phi will be equal to root 3 into 5 kilo minus 1.2 kilowatt divided by 5 kilo plus 1.2 kilo. So now if you solve this for phi, you are going to get phi as equal to 46.7109 degrees. So phi value you have got. Once you know the value of phi, cos phi will be equal to, that implies cos phi is equal to cos of 46.7109 degrees, which will be nothing but equal to 0.6856 as a power factor. So you have calculated the second part of the question. And the last part, that is IL. You know that we know that power is equal to root 3 EL IL cos phi. Power is calculated already, which is nothing but 6.2 kilowatt. That is equal to, power you have already calculated, root 3 into EL. EL is nothing but 440 volts. EL is 440 into IL into 0.6856. So that implies IL is equal to 11.8647 ampere. So this is how you calculate the line current. So this is all about the problem of model question paper 1, which I've solved for module 1 as well as module 2. So stay tuned for the next three modules, module 3, 4 and 5 in my next video. Thank you for watching my video. If you have any doubts, you can post the queries in the comment box. And if I've done any mistakes also, you can always say it to me. Thank you for watching my video. If you like my video, please share as well. Like my video, share among your friends. Thank you.